Okay, so I'm just going to run through a few examples of electron configurations. Again, we'll summarize our sodium example being a 281 species, whereby we have 2 electrons in the first shell, we have 8 electrons in the second shell, and we subsequently have 1 electron in the third shell, giving us a 281 species. We saw that in a previous clip, and we're just going to take a few other examples of atoms. We'll take oxygen in the next instance. We have obviously the lower number, the proton number, telling us the number of protons, and then subsequently the number of electrons. So we have 8 electrons. We can fill up the first shell with 2 electrons, and that just gives us 6 electrons, which doesn't exceed the capacity of the second shell. And so we can place all of those 6 electrons into that second shell, giving us a 2-6 configuration. And we'll then look at magnesium, for example, which is 12 and 24. This one being just one proton higher than sodium, and subsequently just one number of electrons higher than sodium. And you can then very easily see that each element in turn, each subsequent element on the periodic table, builds upon the previous one and simply adds 1 electron. So here we have a 282 species. And we'll just randomly take a smaller one this time. We'll take lithium, for example, something in the same group as sodium, just directly above it, and only 3 electrons this time. But, and as we just said, in the same group, but this time this is going to give us rise to the first similarity, coincidence, or structural piece of information about the periodic table. And if you have a periodic table with you, you will, as we've just said, see that lithium is in group 1 on the periodic table. Likewise, as is sodium. And both of them, coincidentally, but not really, both have 1 electron in their outer shell. Magnesium is in group 2, and coincidentally, but not really, has 2 electrons in its outer shell, and oxygen has 6 electrons, and subsequently 6 electrons in its outer shell as well. So that gives rise to us being able to use the group number as well as our knowledge of how to build up an atom to quickly evaluate how many electrons are in the outer shell. And also, while we're here, sodium is in period 3 on the periodic table, and there are 3 numbers within its electron configuration, the first 2 of those shells being filled. Oxygen is in period 2, 2 numbers in its electron configuration. Magnesium, similarly, is in period 3, next door to sodium. It has 3 numbers in its electron configuration. And lithium, we could predict based on its electronic configuration that because it has 2 numbers, it's in period 2, and we can see on the periodic table that it actually is. And so by linking both period number and group number, we can also predict the electron configuration, in addition to building it up after having calculated or used the proton number to tell us how many electrons we have, going from 2 in the first shell and 8 in subsequent shells.